Warahmatullahi wabarakatuh. The second topics we are going to describe, differentiates between what we call as physical quantities of motion. Physical quantities of motion, for instance, having the equation symbols x, v, delta x. Macam tu. So we start with their names. So generally, if it belongs to what we call as a vector, this physical quantity should be having a magnitude. Magnitude means value, and as well that it has direction. So vector has direction. How about if we call it a scalar? It doesn't have a direction. Okay, I give you something that from this expression, you can see one of them is a scalar product. That's going to be time. I give you 5 seconds. Tell me this 5 seconds is moving in what direction? Is it moving above, to your right, to the left, to the bottom? None. Because it's a measurement of how times lapse, kan? So that 5 seconds, it doesn't show you the direction. So that's how we decide that is a scalar product. Okay. Alright. So when we call it a scalar, likewise, let's start with the symbols of x. Okay. So x is measured in unit meter. The measurement is meter in terms of SI units. Yeah. The same one as when we say displacement, except that the symbol is delta. Okay, follow slowly. The second one for scalar is called as speed. Bearing symbols V. The pair, kawan dia dalam vector is called as velocity. Also have the same symbol as V, or might be U. Okay, but later will be reintroduced again. And finally, an acceleration. Okay, so what is an acceleration? To be discussed afterwards as well. So basically, let's start with between distance and as well displacement. Now, what are these? Anyway, I'm portraying expressions over here. These are expressions that we are going to make use in later time when we properly delve into the topics. We call this as kinematic expression. It was meant to be used for the concept of when a system undergoes a constant acceleration. Okay, so let's now, when we define displacement, the definition tells us how to measure it. That's how it is. So basically, based on the expression, you find that there is a symbol delta over here. So delta represent, the delta alone is a product of final tolak initial. But once we incorporate x, means x final minus x initial. So that is what displacement. In the case of its pair, we call it as distance just now. Okay, so it's a measurement of total path length taken setiap yang dilalui. Okay, I give you an example over here to differentiate between distance versus displacement. Alright, in the case of a distance, let's start. Okay, let's say that you start off being at here. Okay, and then you move to the right 10 meter, and then you turn and goes to -5 meter. I'm gonna add the units so that it doesn't bother you. So what will be your total distance moving to the right 10 meter, and then you turn and reach -5 meter. So that total distance gonna give you 10 meter to the right and additional 5 meter to the left, getting the answer as equivalent to 15 meter in total. That will be a distance. It really doesn't bother whether you are moving to the right or to the left. And since we are measuring in a form of X, so just ensure that everything is X direction. Maknanya arah kanan atau kiri je. But you have to count every meter taken. Macam tu. Now let's rub this away and then deal in the case that it is now displacement. So again we start here, but moving to the right 10 meter and then later on you turn going to -5 meter. So by the expression, it tells us that simply we follow the mathematical. Final position is -5. This is where we have ended, -5. And we originally, yes, stay at 0 awal-awal dia. So it becomes -5 meter. Now what displacement tells us? Well, displacement tells us that it really independent of what happened in between. Maknanya sebelum nak sampai ke -5 tu, we are really tak kisah pun whatever the answer is. But what really matter is where you start and where you end. Okay, where you start and where you end. Okay, and in the case here is delta X. So the measurement is looking at or scrutinizing data in a form of X value. Okay, so that's the difference between what we call displacement versus distance. Now, moving on, we have a second one. We call it velocity. We call it speed. Overall, they have the value of units, meter per second, because it tells us in within 1 second what is your coverage distance. For instance, let's say lah, the number is 5 meter over second. It's actually equivalent to 5 meter distance travel in within 1 second time. So it tells you how far you have traveled in within 1 second. So if we are talking about driving, let's say that 80 kilometer per hour, it really means that in within 1 hour, you have traveled a total distance of 80 kilometer. Alright. Now let's start from there. So that's the idea of what it meant. And now let's look at how do we differentiate in terms of the calculation. So basically, if we are talking about the scalar product, okay, the scalar product over here that does not bear any direction, tak ada arah, then very simple. The calculation will be needed to having the final answer as meter over second, means that the above should bear total distance and over time lapse, masa yang berjalan. But here you have noticed bahawa the internal cooperation of whatever inside dia tu adalah belongs to as well scalar. And then kita dapat juga the parents, the outcome is also a product belongs to scalar. Okay, that's how we decide lah. Now, what would it be if we are talking now about velocity? Okay, I'm going to jot down properly. So, over here is actually speed, which is scalar. In the case that is a velocity, very simple. Though we would like the final answer to as well bear unit meter per second, means that internally it should as well make use of whatever belongs to vector. That means it should be bearing the expression of displacement over time lapse. Okay, but note as well that commonly we tend to reduce our writing to delta x over t, okay, or even x over t. There are times that we reduce it to such. But so long that you understand is the vector quantities, I think that's much more prominence. Lagi penting lah. Okay, so that's what velocity gonna be versus what we call as speed gonna be. But we have another as well that having the same equation as velocity. We call it as instantaneous velocity. So instantaneous, it's actually a representation of at a very specific time. At a very specific time, what is the velocity at that specific time? So by the book itself, the instantaneous at the instant velocity at that instant velocity is the limit of the average velocity as the time interval become infinitely small. So in a very 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 specific time, what is the velocity? That is what it meant by the instantaneous velocity at the instant.